when a body slides down from rest along a smooth 30-degree, the time taken is t. Along a rough same angle theta, the time taken is alpha t. The coefficient of friction between the body and the rough plane is 1 upon root x times alpha square minus 1 by alpha square. So when we compare the motion of this motion of this body along two planes, smooth and the rough plane, let me just make a note of that as well. So smooth and rough. So this is smooth plane and this is rough plane. Acceleration along smooth plane will be equal to g sine theta, and acceleration along rough would be equal to g sine theta minus mu kg cos theta, right? Now, okay, do you want me to describe this derivation? Let us take a minute to go through the derivation, because some of you may not be knowing it. Anyway, I'm not going to describe it in much detail because we've been using this derivation for a long time. I mean, we've at least done 10 to 15 numericals based on the same. So let me just summarize it. Acceleration along smooth plane, free body diagram, normal reaction acting upwards, mg cos acting downwards, mg sin theta, weight mg. Net direction of motion is net direction of motion is downwards. Sigma fy is equal to 0, n will be equal to mg cos theta, sigma fx equal to ma, only force is mg sin theta, so mg sin theta is equal to ma, and therefore ma is equal to g sin theta. Therefore a is equal to g sin theta. Now, how would you define the same case for acceleration due to smooth rough plane? So while you discuss the same acceleration for a rough plane, additional force of friction comes into picture. Everything remains the same. So the only alteration comes here is mg sin theta, the body is sliding downwards, so that will be plus mg sin theta. Friction is acting upwards against the net direction of motion, so that we'll take it as minus kinetic friction plus mg sin theta. What is minus kinetic friction? It is mu k into n plus g sin theta. What is mu k? Mu k is, what is n? N is mg cos theta. So we have mu k into mg cos theta plus g sin theta, or plus mg sin theta is equal mg sin theta is equal to ma, and therefore what would be a from here? A would be minus mu k into g cos theta plus g sin theta is equal to a. Okay, you can watch this one more time and then things will become more clear to you. Anyway, that's the basic part of the solution. Now let's go directly into the solution. So we have two accelerations, one acceleration along the smooth plane and the other acceleration along the rough plane. Now what is displacement along the smooth plane? It is us into ts plus half as ts square. Displacement around rough, SR is equal to UR into TR plus half AR TR square. Both of them are given, pushed down from rest, which means initial velocity would be equal to 0 in both cases, and therefore displacement along smooth can be written as half 0 into 2 is 0, 0 into TR is 0, so we can write displacement along smooth is half AS TS square and half AR TR square. But if we understand that displacement along smooth and displacement along rough, both of them are having the same value. Why? Because both of them are the same incline. Therefore we can say that displacement along smooth is equal to displacement along rough. Let me just write it down here. So we can write down displacement along smooth is equal to displacement along rough, and therefore half AS TS square is equal to half AR TR square. 1 by 2 by 1 by 2 is 1. We plug in these values. Acceleration along smooth is g sin theta, and along rough is g sin theta minus mu kg cos theta. So acceleration into TS square into TR square. It is given to us in the question that TR is equal to alpha times TS. So I substitute TR is equal to alpha TS. So what is TR square? Alpha square TS square. Every other parameter remains the same here. And now in this equation, in this equation throughout, I will divide it by g into ts square. So ts square by ts square, ts square by ts square is 1, g by g is 1, g by g is 1, g by g is 1, ts square by ts square is 1. So what we have now is sin theta is equal to sin theta minus mu k into cos theta into alpha square. What is theta? Theta is 30, sin 30, sin 30, cos 30. Now, what's the value of sin 30? The value of sin 30 is 1 by 2, cos 30 is root 3 by 2. Now, I'll multiply this alpha into the brackets. So, we get alpha square by 2. I'll transpose that alpha square by 2 to the LHS. What we get is 1 by 2 minus alpha square by 2 is equal to minus mu k into root 3 by 2 into this alpha square multiplied inside. So, if we divide this entire equation by 2, so 1 by 2 by 2 by 2, all these 2 will get cancelled. So what we have is 1 minus, right? What we have is 1 minus alpha square is equal to mu k into root 3 into alpha square. If I bring this alpha square to the LHS, what we have is 1 minus alpha square by alpha square into 1 by root 3 is equal to minus mu k. Therefore, what will be mu k? Mu k therefore will be, multiply this equation by minus 1. 1 minus alpha square into minus 1 is 1 minus 1. Minus into minus is plus alpha square. So alpha square minus 1 by alpha square into 1 by root 3 is equal to root k. And if you analyze the given question, the question says that 1 by root x, this coefficient of friction is equal to 1 by root x into alpha square minus 1 by alpha square. I'll compare this equation with the one we have obtained by 1 by root 3. So alpha square minus 1 by alpha square by minus 1 by alpha square. These two terms will get cancelled off, and what we get is 1 by root 3 is equal to 1 by x, and therefore x is equal to 3. So the correct answer here is x is equal to 3.